How to reverse insulin resistance.
Here are the top telltale signs of insulin resistance female patients see in my office.
Top 4 things you could start doing today to help reverse your insulin resistance.
There are thousands of videos on TikTok and other social media platforms talking about insulin resistance and talking about reversing insulin resistance. Most of them giving advice like this.
Second tip is to really minimize the refined carbohydrates. So that's going to be your pastas, breads, added sugars. I put rice and potatoes in that category as well, because what these foods are going to do, they're carbohydrates. They're going to spike your blood sugar. And what happens is every time you're spiking your blood sugar, insulin is released in response to it. So over time, these continuous blood sugar spikes in response to these carbohydrates is going to lead to too much insulin and ultimately insulin resistance.
Essentially the idea that carbohydrates, because they spike insulin, cause insulin resistance. This is going to be part 1 in a string of videos talking about what insulin is, what insulin resistance is, and the ultimate causes of insulin resistance. And we will unpack and uncover whether or not carbohydrates cause insulin resistance. The easiest place to start is to ask ourselves, what in the world is insulin? Insulin is a peptide produced by the pancreas in response to the ingestion of carbohydrates and to a minor extent the ingestion of protein. Insulin works by binding to the insulin receptor. Upon binding, the insulin receptor goes through a process called dimerization. Dimerization is just a fancy term for the process by which 2 proteins bond to one another and form a functional unit. They then go through a process called autophosphorylation. This is just another fancy term for the process by which the left portion of this receptor will add phosphate molecules onto the right portion, and the right portion will add phosphate molecules onto the left. Phosphorylation is one of, if not the most important processes that occurs within our cells to increase or decrease the activity of a specific cellular function, which are the signaling processes that occur inside of our cells. Essentially, the addition of a phosphate can change the structure and function of proteins, either turning them off, turning them on, and or allowing other proteins to bind to them, as we'll see in a moment. The phosphorylation of the insulin receptor allows another protein inside of our cells called IRS1 to bind to the insulin receptor. After this occurs, 2 more proteins called P85 and P119 will bind to IRS1. IRS1 will then phosphorylate this protein complex, allowing this complex to go over to another protein inside the membrane of our cell called PIP2. Yet again, PIP2 is then phosphorylated, converting it into PIP3, which is the same molecule just with the addition of a phosphate. Once this occurs, another protein inside of our cells called PDK1 can bind to PIP3, and PIP3 essentially activates PDK1. This attracts another protein called AKT, and PDK1 will phosphorylate AKT on 2 distinct locations. This activates the intracellular protein called AKT. And in the scheme of insulin signaling, AKT is the protein that makes the magic happen. AKT is the protein that stimulates all of the effects of insulin. These effects we will discuss in the next video.